I'm going to talk about the Pythagorean theorem in this lesson. So the first thing we need to look at is what the Pythagorean theorem is talking about, and the Pythagorean theorem works in right triangles. So you notice if the green is true, well, look at the green, it's a right triangle. Well, then what's going to happen? Well, if we really have a right triangle, then we can use this little equation called the Pythagorean theorem in most cases, which just tells you that if you square the two legs and then add it together, it's going to equal the hypotenuse squared. Now I'm going to actually go through and use the Pythagorean theorem in my next couple of examples. So this first one, it wants me to find the value of x. So how long is that leg in the right triangle? Well, using my Pythagorean theorem, I have a squared plus b squared equal to c squared. What we need to remember is a and b are always the legs, c is always the hypotenuse. So a, I'm going to say a is my x. It doesn't matter which leg we have be a and which one we have b, just as long as obviously one is one and one's the other one. So I'm going to have x squared plus, and then my other leg is the 12, square that, equal to my hypotenuse is 13, and I square it. Continue on. I have x squared plus 144 equal to 169. Get rid of the 144 from both sides, and I find out that x squared equals 25. Now remember, we're trying to figure out what x is, not x squared. So I have one more step. I need to take the square root, both sides of the equation. When I do that, I find out that x equals, remember in an equation, when you take the square root, you have to look at the positive and the negative solution. So really x is going to be a positive or a negative 5. Well, in our problem, it's not going to make any sense for that side of the triangle to be a negative 5. So I found out that for my problem, the x value is going to be 5 centimeters long. Taken care of. Now it asks for the exact value and the approximate. There really isn't any difference here because it came out to be exactly 5. In my next one, here, I'm looking to try to find the hypotenuse. Notice it's opposite the right angle. Well, I'm going to use my Pythagorean theorem again. Do my a squared plus b squared equal to c squared. I know a and b this time. I'm going to say a is 12 and b is 14. And I don't know what c is. That's the y in this problem. And I'm going to continue on. Well, 12 squared is 144. 14 squared is 196. That's going to be equal to y squared. When I add them together, I'm going to end up with 340 equal to y squared. Again, I want to figure out what y is, not what y squared is. So I need to take the square root of both sides. When I do that, I'm going to get a positive and a negative. But what I'm going to do is I'm going to break this off right now. And this is where, being I want the exact answer and the approximate, I'm going to take that square root of 340 and I need to simplify it. The way I do it, I go through and I look for all the factors of 340. Well, I look at it from the starting point and I say, well, it's even, so I know 2 has to be a factor. Well, 2 times what is 340? And that answer to that would be 170. So now I think of 170s in my head. Well, I know that 2 is a factor of that because it's even. Well, 2 times what is 170? 85. What are factors now of 85? It ends in 5, so I know 5 is a factor. And then the other factor would be 17. So what I've done is I've prime factorized it. Now what I look for now is I look for pairs of numbers. Because if I have a pair of numbers, think about 2 times 2 is 4. What's the square root of 4? It's 2. So what that tells me is if I see a pair of numbers underneath the radical, under my square root, I can pull that pair out so that I just have the 2 on the outside. And being I don't have a pair for 5 or a pair for 17, I just multiply those 2 back together, and I have 2 times the square root of 85. So y, coming back now to my problem, y is going to be plus or minus 2 root 85. And again, being this is a side length of a triangle, the negative is not going to make sense in this problem. So that is going to be 2 root 85 feet long. There would be the exact value. Now the approximate value, all we have to do is we have to punch it on our calculators, and we're going to find out that the approximate value for that is going to be 18 and I'm going to round to 2 decimal places. It comes out to be 18.439. So if I go 2 decimal places, that's going to be 18.44 feet. Exact, approximate values for my hypotenuse in that right triangle. The last thing I'm going to talk about are called Pythagorean triples. See Pythagoreans in there, so it's going to have something to do with the Pythagorean theorem. And it's going to be 3 numbers. Notice that there are going to be whole numbers, 1, 2, 3, 4, 5, 6, 7, so on and so forth. It could be any of those numbers that satisfy the a squared plus b squared equal to c squared. Now, one example, probably the most famous Pythagorean triple, is the 3, 4, 5. Used a lot in right triangles. We can use it because we know if we have 3, 4, 5, we have a right triangle, which means we have a right angle. Very beneficial. Now, another Pythagorean triple, just using that 3, 4, 5 concept, if we were to just multiply those all by, say, 2, we're going to get 6, 8, 10. If you plug those 3 numbers into a squared plus b squared equal to c squared, the equation holds up, therefore 6, 8, 10. We could take the 3, 4, 5, multiply it by 3, and get another Pythagorean triple. Now, another Pythagorean triple would be the 5, 12, 13. And again, we could take the 5, 12, 13, multiply it by any number, and you're going to get another Pythagorean triple. This is a lot of times referred to as the parent Pythagorean triple. This would be one of the children of it. Same thing with the 3, 4, 5. That'd be like the parent one. See if you can come up with other ones, and tell me in class that you found another one and give it to me. Just curious how many we can come up with. And then that's going to conclude the Pythagorean theorem portion of this lesson.